Let's go ahead and look at this problem. So this is just a simple 2D problem, and we've got a force F here. Notice we don't know the magnitude right now, and we don't know this angle theta. Then we also have a 50-pound force that's on the x-axis. I've got this little u-axis here, which is dropped down 45 degrees from x, and then I've got another force right here, so the 90-pound force. And this one we're given that little triangle. Now what we want to do is we want to find the magnitude of F and its direction theta, and we want to do that if we know the magnitude of the resultant force is 80 pounds directed along the u-axis. All right, so here's that u-axis. So my resultant is going to be directed along this line. All right, so let me get a different color here. Pick this one, and let's draw that on here. So basically your resultant is going to lie right here. All right, and the magnitude of that is going to be 80. All right, so technically this shouldn't have the little bar up there because that's just a scalar, but the magnitude of that resultant will be 80. It's going to lie on this line. Okay, so knowing that, we need to find F and theta. So let's go ahead and get started. All right, so let me switch back to a better color here. All right, so first thing we need to do is recognize what the resultant force is. So remember, the resultant force is the sum of the force vectors. Okay, so I know that. So that means what I need to do is I need to find my force vector, get them in Cartesian form, and that includes the resultant. Okay, so I need to write Cartesian vectors for these four forces. Okay, so let's do that first, and then we'll see where to go after that. So first let's do this F force right here. Now I don't know anything about that force, but I know it's pointing up and to the right. So that means my force in vector form is going to be F times cosine theta. All right, because the x component is adjacent to theta, so that's going to be cosine. Let's put an I, and it's positive because it's going to the right. And then it's going up, so that's going to be a positive y component. So I have plus F sine theta. All right, and again, that's because my y component is going to be basically this side here. All right, and then that's J. And when I say it's on this side, that's because even though it's technically over here, if you think about it, you could slide this over and you get the same thing here, right? So it's opposite the angle. Now, that's all I know about that. I can't do anything else with that one. Now let's look at this 50-pound force. Let's put it right here. Now this one's pretty easy, right? This one just lies on the x-axis. It's just pointing to the right. So the unit vector for the x-axis is what? You remember? It's going to be I, right? So it's a positive 50I. All right, and these are all in pounds, by the way. Now let's look at this 90-pound force. So we'll call it F90. So this one is going down and to the left. Okay, and then we have this little triangle. So for the x component, that is basically going to be right here. So that's to the left, so it's going to be negative. And then we're going to have 90, and then we need to use the triangle. So remember, we're looking for the x component, so you want to find the side of the triangle here that's parallel to that x component. So that'll be 3, and then we put it over that hypotenuse of 5. And this is the I component. And then we can do the y component, which is right here. It's going down, so it's negative. So we'll have negative 90 times 4, because this length here of 4 is parallel to the y, and then put it over 5. And that's J. All right, so now we've got that. And this is pounds too. Now, the last thing that we need to do is the resultant. Okay, because I know it lies on this u-axis, magnitude's 80. So with that, it's going down and to the right. So the x component will be positive, and we've got this 45-degree angle here. So we're going to have 80 cosine 45i. And then the j component, this is going down, right? So we're going to have a negative 80 sine 45j. And then let's go ahead and simplify this one. I forgot to simplify this one over here, but that's okay. So 80 cosine 45 is going to be 56.57i minus 56.57j. And that's pounds. So now we've got those things done. All right, so that's really the hardest part, is finding all the vectors. Now we've got that done. And now I know that my resultant force has to equal the sum of the forces. Okay, so that means, here's my resultant force, that means 56.57i, whoops, it should be a minus 56.57j. That's going to equal all of these different forces. Okay, so we're going to have the f cosine theta I plus f sine theta j. We got our 50i, and then we've got these two here. All right, so minus, that's 270 over 5i, and then we've got that minus 90 times 4 over 5. And let's see. So that'll be 360 over 5j. So now we've got all of this written out. Now remember, the I and j components, those are like two separate things, okay? You can't mix and match them, right? So what we want to do is we want to separate out the I components and then the j components. Okay, so on the left side for our I component, we're going to have 56.57 from this right here. And then we want to pull off the I components on this right side. So that's that one, and that one. Okay, because all of the x direction force components go together. All right, so then we end up with that. Okay, now I can't solve for my two unknowns here. I have two unknowns, one equation, right? So I can't really do anything with that. So let's go to the j equation, see what we get with that. So now I'm going to have negative 56.57, and then that's got to equal f sine theta minus the 360 over 5, which is 72, but we'll leave it as 360 over 5. So now I've got this. I have two equations, two unknowns, and unfortunately I've got cosine and the sine. Now what I always do when I have this situation is I want to try to get a tangent. Okay, so I'm going to go up to this top equation here and I'm going to solve for f. All right, so if you simplify everything, take these, move them over, then we divide by cosine. If you do that, you're going to get 60.57 over cosine theta. So this is an equation for f in terms of theta. And now what we're going to do is we're going to take this and we're going to plug it in right here. All right, and then that's going to give me that tangent function. So if we do that, we get negative 56.57 equals 60.57 over cosine theta times sine theta minus 72. All right, so if we look, we've got tangent here, sine over cosine. And then we can move this over here. And once we do that, we get 15.43 equals 60.57 tangent theta. And now we can solve for theta by doing the arc tangent of 15.43 over 60.57. All right, so we just do the arc tangent. Whoops. I'm not sure what that number equals there, but that's what we do. And then theta is going to be 14.29 degrees. All right, so that's one of the values I needed. And now that we have theta, how would we find F? Well, that's going to be easy, right? I have this expression right here. So I'm going to take this theta and I'm going to plug it in right there. All right, so we're going to get F is 60.57 over cosine of 14.29. And with that, we get that F is 62.5 pounds. Okay, so that's how you find those two unknowns. So the key on this one is realizing it's going to be easier to solve this top equation, get cosine in the bottom, so then when you plug it in here, you get that tangent theta. All right, a lot of people try to do some crazy algebra to get this theta, but that is typically the easiest way to go about that. All right, I'll see y'all next time.